Gauss principle to determine the density of nitrogen oxide at STP. Okay, let's look at here. First, we're going to look at our equation. PV is equal to nRT. We asked to define the density of a particular substance. So density is equal to mass over volume. So in this particular equation, in order for us to get mass over volume, we have to use our number of moles and our volume, which will give us that. So if we substitute the number of moles back into the equation, what we would end up having is, we know that the molecular weight of a substance is equal to the number of grams over the number of moles of a particular substance, which means that moles is equal to grams over molecular weight, which means we can substitute that in grams of molecular weight back into the equation, which would give us PV is equal to grams over molecular weight times R times T. Now, we know that we have the number of grams, but we know that volume is equal to grams over volume is equal to our density. So we can take this equation and rearrange it so that we can get an equation that looks like this. Grams over volume is equal to the pressure times the molecular weight divided by R times T. And if we can use that equation, then we can determine what our density is. So let's clear our screen. Let's rewrite our equation. So we have G over V is equal to P times molecular weight over R times T, which is equal to 1, that's the pressure at STP, times 44, that's the molecular weight of N2O, times the ideal gas constant, divided by the ideal gas constant is 0.0821, times standard temperature, which is 273, which would give us a density of 1.96 grams per liter. Alright, oh, I think that should do it. That's a wrap.